yourselves in your head, so it shouldn't be too much of a challenge. All right, so we went through all of this. Done, done, done. So now we're going to go into our steps for solving a rational inequality, which are a little bit different than when we have a quadratic inequality. All right, so step one's kind of the same as our quadratics. In quadratics, we wanted to get it into standard form. The same thing applies kind of for rational inequalities. So the first thing we want to do when we have an inequality that has a fraction, that's what rational means, we want to write it so that 0 is on one side. So we want to move everything to the same side, so put 0 all over to the left. Or put put everything over to the right, so 0 is on the left, or put everything over to the left so that 0 is on the right, however way you wanted to do it. So move everything so that you are left with just a 0. And then on the other side, we want just a single fraction on the other side. So that means we're going to have to either add or subtract rational expressions, which you guys should know how to do because we did that last chapter. And we did it when we were doing our equations that had rational fractions in them. Okay, so we want 0 on one side, and on the other side you want a single fraction on the other side. So then in step 2, this is the crucial part. This is where you're going to get your specific values. In quadratics, we got our specific values by solving it and getting our x-intercepts. For rational inequalities, we want to determine the numbers that make the numerator or the denominator equal to 0. So pretty much I'm going to look at my numerator. I'm going to say, what is the value that makes my numerator 0? And that's going to be one of my key crucial points. Then I'm going to look at my denominator. I'm going to think, what makes my denominator equal to 0? And then that's going to be my second key crucial point. And then through those 2 points is where we're going to get our intervals. So then we're just going to make a basic number line, and we're going to divide it into intervals. So divide a number line into intervals. After we have our intervals figured out, we're going to find the intervals that satisfy the inequality, which is kind of what I showed you with quadratics, but we didn't really do it because it was just easy to see it graphically. But in this case, we're going to have to pick tester points for those intervals. Okay? Now there's one more important thing that we do need to keep in mind with rational inequalities. Because in step 2, we determine the values that make my numerator and more specifically my denominator equal to 0. Okay? Because that's going to be the points that make it go from positive to negative. Once you know where something is 0, that's your change from going from negative to positive or positive to negative. It has to bypass through that 0 mark. If one of your intervals is the number that makes the denominator equal to 0, we cannot put a bracket around it, even if my inequality sign has equal to, because it can't equal that number because it makes it undefined. So for step 5, you're going to consider the endpoints separately, which only means you have to think about your parentheses and your brackets when you're making your intervals. Okay? Because I'm not going to be able to put a bracket around the number that makes my denominator equal to 0. That's always, always, always going to be a parenthesis, no matter what the inequality sign is. Okay? All right, so let's work through this. Maybe it won't seem so complicated as the steps make it out to seem. So here's our first rational inequality. We have -1 all over x minus 3 is greater than 1. So step 1 tells us to get 0 on one side, so it's probably easiest to move just the 1 over to the left. So subtracting it over, I get -1 all over x minus 3 minus 1 is greater than 0. So now I've got 0 on one side. Now I have to finish the rest of step 1 by turning this into a single fraction, which means I need to make a common denominator. Right now that 1 has a denominator of 1. So what else does this need so that it's the same as this one, the first one? Another x minus 3, so I'm going to multiply it by an x minus 3, multiply by an x minus 3. So now my common denominator is going to be an x minus 3. This stays a -1, nothing changed there. Here I have a -1 times an x, so negative x. And I have a -1 times a -3, which would be a positive 3. Combining like terms gets me -x plus 2 all over x minus 3 is greater than 0. So all of that to get step 1 done. Fortunately, step 2 is very easy. What makes my numerator 0? 2. Positive 2, right? Yeah, because I would subtract and divide by a negative. So for my numerator, if we do -x plus 2 equals 0, we end up getting x is equal to 2. For my denominator, x minus 3 equals 0. So what makes my denominator 0? Positive 3. So now I'm going to use these two numbers, and I'm going to throw them on a rough number line. So here's my rough number line. I'm going to have 2 here, 3 there. So now I'm going to have 3 different intervals. I have the outsides, and I have the inside. Okay? So I'm going from -infinity to 2, 2 to 3, and then 3 to positive infinity. So now what I need to do is I need to find the intervals that satisfy, and we always go back to the original inequality. So someone give me a number that is less than 2.
1.
Even easier.
0.
0. I mean, we could do 1, that'd be fine. But if I'm going to try to do this mentally, I would pick 0. So if I pick 0, so I'm picking 0. If I plug in 0 back into the original, what do we get on the left side? Make your x 0. We get -1 over -3, which is 1/3. Is 1/3 greater than 1? No. So I'm going to put an x there. So that means this is not the interval, which probably means this one also is not the interval. Just like we did with the quadratics, it was always the outsides or the inside. So it's probably going to be the inside. But let's just check it to make sure. Someone give me a number between 2 and 3. 2.5. All right, so 2.5, a little bit harder to do mentally. If I do -1 divided by 2.5 divided by 3, which is just -1/2, I get, I'm in my space, I get a positive 2. Is 2 greater than 1?
Yes.
Yes, so that means this is a true interval, which means this one probably is not going to be 1. Someone give me a number greater than 3.
4.
4. If I plug in 4, I get 4 minus 3 in my denominator, so 1. So -1 is -1 greater than 1? No. So my only true interval for the original is between 2 and 3. So now we got to be careful. Which number between the 2 and the 3 is in the denominator? That makes it undefined, I guess I should say. Doesn't 3 make my whole function undefined?
Yes.
So 3 has to be a parenthesis. That has to be a parenthesis, no matter what. The 2 doesn't really matter because it's in the numerator, but if I go back to my original inequality, do I have an equals 2 sign? No, so it's not going to be a bracket, so it's going to be another parenthesis. So my answer is the interval from 2 to 3. If my original problem did have an equals to, then it would be bracket 2, 3 with a parenthesis. That 3 would still stay with a parenthesis. If my original problem was flipped and it was less than, so if it was less than, then what would my answer be? My left interval would now be true, because 1/3 is less than 1. So this would be going from negative infinity to 2, union, and then 3 to positive infinity. My sign was a less than. If it had a less than or equals to, that would just make my 2 have a bracket, but my 3 would still be a parenthesis. Okay? And that's where I think we're going to lose like half points. Because we're going to forget to only use a parenthesis on the number that makes your function undefined. Okay? All right, let's do another one. Let's do, no, we won't try one on this, just one. X minus 2 all over x plus 2 is less than or equal to 2. That's what we're going to do first. Move the 2. So x minus 2 all over x plus 2 minus 2 is less than or equal to 0. Next move, make a common denominator. So what do I need for my second? I need an x plus 2 and an x plus 2. So my single fraction is going to have a denominator of x plus 2. On top, x minus 2 stays. Now be careful, we're distributing a negative 2. So a negative 2 times x is negative 2x. A negative 2 times a positive 2 is a negative 4. It's less than or equal to 0. Combine like terms in your numerator, so it looks like you get a negative x minus 6 all over x plus 2 less than or equal to 0. So what value makes my numerator 0? What would that be? Do some mental math. Add 6, divide a negative, so negative 6. And then what makes my denominator 0? Negative 2, good. So then just make a quick rough number line. So negative 6, negative 2. So we've got our interval in the middle. We've got our 2 intervals on the outsides. So now let's pick some tester points. So something less than negative 6. Actually, let's do this. Let's pick one that's easiest. What would be the easiest number to evaluate with? 0, right? 0 just makes all the x's go away. 0 would be in the far right interval, because that's greater than negative 2. So if I plug in 0 up to the original, those go away. So what am I left with on the left? Negative 1, right? Because negative 2 divided by 2 would be negative 1. So if we plug in 0, I'm left with negative 1. Is that less than or equal to 2? Yes. So that means that's going to be a true. Okay, it's never going to happen that these two right next to each other, the outer and the inner, are going to be the 2 intervals. So if it's true here, that means it can't be true here, and it means it's going to be true here. So sometimes it's just even easiest just to find 0, figure out which interval it's in. If it's in the middle one, and it's false, then it's got to be the 2 outer ones. If 0 is on one of the outer ones, and it's false, then it's got to be the inner one. Or if it's in the outer one and it's true, then it has to be true on the other outer one. Does that make sense? So it kind of lets you do less work. So if it's true for the outers, what's my solution going to be? Left interval is what? Negative infinity to negative 6. Is that going to be a parenthesis or a bracket? And it's going to be a bracket because the original inequality sign has an equals to. Union, parenthesis or bracket at negative 2. That's going to be a parenthesis because that's your denominator, 0, -2 to infinity. Okay? Any questions? All right, let's quickly do some practice problems to make sure we've got this. So if you need to grab